Hello, and welcome back to week 7 after our brief pause last week. Make sure you check in, see all the announcements. I've got a couple of questions for you all about the gradebook because I'm thinking there's some things you might not be able to see that I can see, and I'm just trying to sort that out. But let's dive into our topic for today, which is about reading geologic maps. Okay, so, whoops, I need to go back a slide. All right, so we're going to be investigating how to get as much as we can out of geologic maps. We'll look briefly at why we have multiple different geologic maps for Minnesota. And then I'll go through an introduction about the essentials of a geologic map. And that will include thinking about vertical slices through Earth, which geologists call cross sections. We'll look very briefly at some of the specialized symbols on geologic maps. And then we'll move beyond some of the intro summary maps. And I'm going to wrap up by sharing some information on the various Minnesota geological maps that are available. So with that, let's dive in. So the first thing I want you to notice, or you may already be aware of this, is Minnesota is complicated. And that's because what we call bedrock underlies the sedimentary cover material. So let's just pass this statement here. Bedrock means whatever the solid rock underneath sediments is. Any sediment that hasn't yet been lithified is usually quaternary. Oh, and this should have been a capital Q, whoops, in age. Quaternary essentially refers to the most recent time chunk. It includes the Pleistocene and then more recently the Holocene. It goes back to 2.6 million years. So the young stuff is quaternary, that's geologically young, and it generally hasn't been lithified. So don't worry about the diagrams yet. I'm just going through some terminology here. So bedrock is whatever the rock type that's underneath that sediment on top of it. Basement, it may be bedrock, but it's also used for the oldest or older rock that is down below. So if we just move over to the right-hand side now, I want you to look at the diagram at the top. This is a vertical slice through part of southeastern Minnesota. So the land surface, and I should say that we call these vertical slices cross sections. So the land surface is where I'm moving my cursor, right here, this line at the very top. And the uncolored area where it says quaternary glacial sediment and soil, that's all the sediment that's on top of the bedrock. And in this case, the purple, blue, and yellow layers that have been a little bit folded and deformed are all bedrock. These are layers of sedimentary rock that all have their distinct characteristics. Underneath that bedrock, we have an area in gray that's labeled Precambrian. This is just an age term, and it refers to the rocks that the yellow, they aren't necessarily yellow when you look at them in the field. That's just how they're colored here. How these yellow sediments were deposited on top of. So we're just lumping that basement together and we're naming it based on the age. If you go down to the lower diagram, which is very dated, but I kind of like it because it captures some of the same layers. So you can go back and look at this, but this is effectively the Minnesota River Valley. And what it's showing is what the shape of the land looks like in the Minnesota River Valley, if you're somewhere between Minnesota and Wisconsin. And what you're seeing in here in the area that I'm pointing out right now with my cursor is the quaternary sediment that has been deposited by the river. Some of it may also have been deposited by earlier rivers. Anyway, it's a whole bunch of sediment filling up that valley. And then down, so you have underneath that valley that's been carved into the bedrock, we have a Precambrian basement. And on this diagram, it identifies it as Precambrian granite and gneiss. So I just want to draw a simple cross-section now. So bear with me while I go here. Try again. So for a very simple cross-section, oops, it's upside down. Bear with me. I have to just change this. Okay, so I'm just free drawing a cross-section. What happens in Minnesota is we have the shape of the land. That's, I'll just draw a little person walking there. That's the shape of the land. And depending on how much has been removed, how much has been deposited, we often have a varied thickness of sediment at the surface. And often that sediment completely covers the rocks. And that will be a quaternary sediment. This quaternary sediment also gets called surficial sediment. And that comes from the word surface. And so down underneath that sediment, we move into rocks. And I'm just going to draw a series of flat layers of rock for our purposes. So I'm going to show them in with slightly different patterns here. But they're continuous across the area. And then the boundary with whatever the basement is, and I'm going to make that be a pretty horizontal line, and I'm going to just show it with these little crosses. So this is basement, and sometimes you see the term local put in front of bedrock, because what the bedrock is depends on where you are. So this is a simple cross section. You can think of it as a vertical slice. And remember that this is the land surface. And so geologists spend a lot of time drawing cross sections. Let's go back to the slides now. So I'm going to, come along, it's supposed to advance. All right, so let's take a closer look at the essentials of a geologic map. I've put a couple of, well, more than a couple, several geologic maps into D2L for you. So, and as part of your warm-up activity, you looked at this one. So what are the essential parts of a geologic map? The title, that always tells you something about what is being shown. Always look for a title. And, oh, well, every map is supposed to have a north arrow. This one lacks one, but we'll ignore that oversight. Every geologic map should have a scale. And here on this map, we see the scale in miles and kilometers. And then there is all the other information, which you can lump together as the legend or key. But the legend or key is usually divided up into several components. In this case, we've got our description of map units down here. There is, and we'll look at exactly what that is in a moment. There is also a piece of information not found on all maps. It depends on the complexity, called a correlation of map units. And in this case, that's over here on the right. There is usually a separate part of the legend that includes information on symbols. On this generally simplified map, those symbols are way down here at the bottom. There's particular kinds of faults with little dragon's teeth on them. Then there's also faults, those are breaks in the crust with dark lines. And then they've chosen to highlight iron formation, a particular type of rock, with these red lines. And if you look briefly at the description of map units, you'll see that there's some iron formation in several of those units. Other information that you would find on fuller maps would be all the sources, who did the mapping. If one person did most of the mapping in the north and another in the south, they'd have a little inset map that showed that. And there should be other information, including the date the map was published and who published it, amongst other pieces of information. So those are the essential parts of the map. Let's dive into them a bit. So first thing we're going to look at is the description of map units. So here we're down in the lower area. So the rocks get divided up into different units. And for a map of this size and scale, a lot of units get lumped together. But each of the units is a different color. And that usually ties in to the rock type. So here, if we see this green color, we know it is red shale. How is this description of map units organized? It goes from youngest on the top left down to oldest at the bottom right. We if there are columns of any kind in a legend or key, we read them just like Western newspaper columns. The youngest unit will be at the top left, and as you go down, it gets older and older. And then you move to the next column, and as you do that, you're moving to the next oldest unit, and it gets older and older and older until you go down to the item on the bottom right. So here, the quartzite is older than the intrusive rocks that are shown in this pale purple color. So we know just information on the rock type, that's part of this descriptive information, and we know something about their relative age now. What usually happens is each of these colors gets identified with a bunch of letters, and that's to help one pick out what each color is, because sometimes there's colors that are kind of similar. Look at this color here, extrusive rocks of dominantly mafic composition. One could confuse that with the color down here, migmatitic gneiss, amphibole granite, and other high-grade metamorphic rocks. So let's just take a look at, oops, hang on. All right, so here we are. This is a map for an area in Alabama. Good geologic map. There's a lot of information on here, but the two areas that I've highlighted with these red circles have some information in this case, the orangey area, TE1. In this case, the T stands for tertiary. So if we're decoding these letters, the first letter, and sometimes it's a funky symbol-like thing, like up here, this is a P with two lines on the, I guess, the stem of the P. That's how we denote Permian, which is one of the time chunks. So everything after that initial letter tells us something about the rock unit. So first letter is the age of the rock. The following letters tell us about the formal name of the unit. And sometimes you have 3 or 4 letter combinations. I'm going to go back a slide now. So the other map that you used in your warm-up is not a bedrock geologic map, but instead it's the quaternary map. So this map, let me actually go back one more. This is our bedrock geology, all the rocks that are underneath that sediment cover. And then here we've got the characteristics of all the quaternary sediments. So this postcard map has all the same essential elements. It's got our description of map units and a correlation of map units. Now, there's a few extra bells and whistles here. We still read it going from youngest, getting older, 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 move over to the next column, older, 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 down to the oldest unit. Here, they're calling it weathered bedrock. So that's whatever the rock underneath the sediment is. And usually it is weathered. It's somehow chemically and physically weathered. But here, they've also divided these sediments up. And what you'll see is that it says sediments associated with the Des Moines lobe. And then as you go down, sediment deposits associated with the Superior lobe. deposits associated with the Rainy Lobe, deposits associated with the Wadena Lobe. Now, oh, I misled you on one thing. This really annoys me. So here, description of map units, it goes down to here. There's actually a break here. And here it has older deposits. Those would be deposits older than the Wadena Lobe outwash. So they've kind of separated out much older material down here. And it says old till and weathered bedrock. But going back to what I was saying before about how the description of map units is organized, it's organizing them based on the lobes of ice that moved across Minnesota during the Quaternary, or more specifically the Pleistocene. And they deposited sediments. And for reasons we'll get to later, the characteristics of each of these, or the sediments associated with each of these ice lobes is somewhat different. The physical area or geographical area that those lobes crossed is also different. What you'll notice here for the deposits associated with the Des Moines lobe, there's kind of this area in here, and then it sort of, well, it gets tricky once you get further north, but there's a distinct area. For the deposits associated with the Rainy Lobe, mostly up here in northeastern Minnesota. So we've got our description of map units. And some of the terms here, till and moraine, etc., all have to do with glacial sediments, sediments deposited by ice. That's something we'll be looking at later. What I want to look at now is this correlation of map units. This is much more complicated than the correlation of map units that we looked at for the bedrock geologic map. A correlation of map units is a way of trying to show how the units that are mapped are distributed geographically, usually west on the left, east on the right, but it also shows how they are related to each other. If they touch, that means that on a map or out in the field, you can walk from one to the other, essentially. If there's a break, it means there's evidence of some kind for there not being continuous deposition. Something was either never there or is missing. So the correlation of map units is much more complicated. I'm just going back to the previous slide here. When we looked at this correlation of map units here, one thing that's important is it shows the actual age of the units in here. These are all terms for age: Archean, Paleoproterozoic, Mesoproterozoic, Paleozoic, and Mesozoic. And instead of giving the rocks their descriptions, it either gives them just an age, and that's because this is a simplified map, or some other information about the name. And what we're seeing here is how some of the units are spread out west to east, and how rocks of different type actually formed at about the same time and are therefore quite likely linked if we're trying to interpret their tectonic setting. So let's move forward now. This is a zoom in on that correlation of map units from the bedrock geology. As I mentioned, it's quite specific about the age of the rock relative to looking at the description of map units where you know it's in pretty much the right order. It doesn't give you a name for the age. Once again, this is still very general information. There aren't actual numbers here that would give you what we call absolute ages. And as I mentioned before, it also tries to show how the rock units in different parts of the state correlate with each other. So here you can see this brown color on the map is designated as correlating with the Keweenawan supergroup, but it's most likely farther to the west. And here, these two units, and I'd have to go to the description of map units to see what they are approximately the same age as these two groups, the Mille Lacs and North Range groups. And the fact that they are contemporaneous, in other words, form at the same time, suggests they somehow are related. Maybe the same tectonic event is associated with them. So then there's all these extra symbols. This is a completely different geologic map. I'll say it's a full geologic map, one used by geological professionals. So they have a whole bunch of extra symbols on them, and there's usually a key showing what they are. And the range of symbols that gets used depends on the type of rocks or sediments that are present on the map. One of the really useful symbols is one that shows the orientation of layering. So here, what I've pointed out is if you've got rocks that have layers, or in other words, sedimentary layering, or maybe metamorphic rocks that have some kind of metamorphic fabric, we measure the orientation of that fabric using what we call a Brunton compass. And the measurement that we take defines the orientation of that layer in space. And it's called a strike and dip. And here, if you look at where this red arrow is pointing, there's this funky symbol where there's a line, and then there's a little tick on one side and a number. This is called a strike and dip symbol, a strike and dip symbol. The number is the dip. That's the angle that the layers are going down into the ground at. And the little tick points in the direction that they're going down towards. So that's just one of the myriad of extra symbols. Other symbols are ones that get used for faults. Those are breaks in the crust where one package of rocks has moved against the other. And one of these symbols is this heavy line here with these triangles, think of them as dragon's teeth maybe, are on. And that gives us information about the orientation of the fault. So those are just a few of the symbols. Now, the next thing I want to think about is, okay, there's geologic maps out there. But in your classroom, I'd imagine it's kind of difficult to work with large paper geologic maps. There are a myriad of maps out there. Many of them are no longer available in print. One can download them, but then one either has to have good large screens or one has to have a way of printing them out. So I'm going to direct you towards some of my favorite maps for working with kids. So as you will have noticed, we're going to the Minnesota Geological Survey here. They are the Minnesota entity that produces geologic maps. And they have tons and tons of maps. But figuring out or finding the maps you want, I still find it's a bit unwieldy. I'm never quite sure where to go. So the first stop is usually going to education and outreach at the MGS website, which I hope you have bookmarked by now, and then going to classroom materials. And you scroll down and you get to some of them, like those postcard maps we've looked at. I've also uploaded some of those into D2L for you. Now, over here on the right are two of the, I call them the dinner mat sized maps that are available. I really like these because they're not unwieldy. The big issue is they are, I'm so sad, not available in paper anymore. You have to download and print them. And I'm not sure whether it's on 11 by 14 or maybe slightly larger paper. Where do you find these two maps? They're in the state map area of publications. The number of the map is way up in the top right-hand corner. They are filed under state map if you go to the list of publications. The two that I've shown here, ooh, I think I've goofed up. They are the Bedrock Geologic Map, which is S19, and a Quaternary Geologic Map, which, bear with me while I try and see this, I'm thinking it might actually be S4 rather than S6. There's also a hydrogeological map. But what I like about these maps is they are manageable. They have it's hard for you to see, but they've got the little symbols or the letters for each unit. So students get used to using them on this official map. Now, the big drawback with these maps is they are quite dated. They are not the most recent geologic maps. So it's give and take. I'm going to just move to some more recent maps now. Oh, and by the way, I'll be putting these into D2L for you. So another really valuable resource is the Minnesota Geological Survey County Geologic Atlases. To find out about these, go to Data Mapping and Programs on the Minnesota Geological Survey website and select County Geologic Atlas, and you'll get to this page. And this tells you all about the County Geologic Atlases. So what these are is they are a suite of maybe 5 to 8 big map plates that get produced by the Minnesota Geological Survey. And what happens is a county will contract with the Minnesota Geological Survey to make a county geologic atlas. This is an initiative that started in the metro area as people realized we need to know about the local geology for managing our environment, every aspect of development, etc., etc. And gradually, the Minnesota Geological Survey has been contracting with more and more outstate areas to produce these county geologic atlases. So the Minnesota Geological Survey makes the geological part. And then the DNR will piggyback on that to make a hydrogeological component where they look at the geology, but they present it in the context of surface water and groundwater. And we'll be looking at surface and groundwater later on in this course. So how about using these county geologic atlases? Well, they are available online, and I have no idea what your situations are with online access in schools. There are paper copies available for some of the county geologic atlases. This is something where you would need to ask the Minnesota Geological Survey if they have any. Each of the atlases, as I mentioned, are full geologic map sets, and they are the maps that are used by professional geologists. So if nothing else, if you could get one for your county, the county where your school is, and put them up on the wall, they might be interesting and useful. So on this page, you can find out which counties have geologic atlases. So that is a wonderful resource for you. So that is an introduction to geologic maps. Email me if you've got questions about geologic maps. Thank you.